Here's Chapter 9, Exercise Set B. We deal with hypothesis testing here, and here is the first problem. The following observations were made on fracture toughness of base plate of 18% nickel maraging steel. Do the sample statistics suggest that the mean modulus of rupture exceeds 75? We have 22 measurements here. Using these 22, we can find out the mean and the standard deviation, but they're given here. These are the sample mean and sample standard deviation. Now, set up the hypothesis. What is the null value mu0 given explicitly as 75? This is not the null value. This is x bar that you have to use in a problem. Null is the one that didn't come from the sample. And how about the alternative hypothesis? Well, the problem set exceeds, so that gives you the direction for the alternative hypothesis. And here they go. Null, mu is about 75. Alternative, mu is significantly bigger than 75. Another indicator besides this term exceeds, well, this means 77.33 is bigger than 75, so that gives you another indicator about the direction of this mu. Alright, let's go over to 1.2. Test your hypothesis using the level of significance of alpha equal to 0.05. We have a number of different methods to handle this hypothesis testing. Now, if you want critical value method, stay with me in this video. If you want probability value approach, then we're going to do this in the next video. For the other methods, well, we'll do those in still other videos. Here we go, critical value approach. And let's begin with the sample statistics here. And sample size of 22, sample mean, sample standard deviation, just computation of all these are here. Standard error and degree of freedom, of course, they are simple to find out. And here is the initial picture. Outline, center, end, and finally shade. And end and shade part must reflect the critical value approach. Here we go. Outline, we have the t-curve, and the center, 75, the null value. End, this is a critical value, and shading, of course, have to reflect that critical value approach. Blue for null, red for alternative, and the red part corresponds to alpha value of 0.05 or 5%. This is a critical value you have to find out, and compare this critical value with the observed mean of 77.33. If 77.33 falls into blue region, that's too close to null, so null wins. If it falls in the red region, then too far away from the null, so null is rejected and alternative wins. So what is this x2? We can find out like this. T-score is end minus center over SC, isn't it? In this particular case, end is this critical value x2. Center is 75.0. And the standard error is standard deviation over square root of the sample size. Is 5.037 correct? Yes, that's the sample standard deviation. So this is end minus center over SE, correct? Now, you have to set this one equal to appropriate t-score, as you have done with confidence bounds and confidence interval. So let's go to t-curve and let's find out t-score associated to this 5% on right hand side. And here we go. This is a t-table. Oops. Okay. Okay, here is a t-table. And we need this 5% here, so we have to look at this 5% column. And we have to go down to the degree of freedom of 21. Sample size is 22, so we need to go down to 21, and this is a t-score 1.721. 1.721. So this is 1.721. Solving this equation here, you're going to get the x value. Once you find out the x value to put right here, you can find out where the 77.33 fall. Does it fall in blue and does it fall in red? Well, here's a computation. Set up the equation and then solve for x. That means this endpoint is 76.85 approximately, which means 77.33 is going to be bigger than that. Let's go to the conclusion. 77.33 falls in the red region, too far away from the null. So we reject the null hypothesis and accept the alternative hypothesis. This is the critical value method. A quick review. Here is the initial picture. End and shade must reflect the critical value, and you're looking for the critical value pretty much the same way you did for confidence bound.